Hi, my name is Bahadur Ahmedov. Welcome to the course of Probability and Statistics. In this lecture, we are going to discuss the estimation of the population proportions. And as usual, we are going to discuss how we can do this as a point estimation and how we can construct the confidence intervals in order to estimate the population proportions. So the first of all, we basically need to define what is the population proportion. And in this sense, I would like to remind you what was the binomial experiment. Binomial experiment is a probability experiment where we are going to have always two outputs, and the probability of success is denoted as P. So this P actually is the population proportion. So in order to explain to you the close connection between the population proportion and the binomial distribution, I would like to give you a small example, a toy example. So let's say I've got a box with 5 red balls and 4 blue balls, for example. Then you can create a binomial experiment where you're going to choose a ball, then denote whether you picked the red one or not. So then you put this ball back to the box and you do this experiment many times. And every time when you choose a ball, probability that you will get a success, basically probability that you will get a red ball is going to be equal to the 5 over 9. So this is very similar to the concept of the proportion. So if I would like to know what is the proportion of the red balls inside this box, what I have to do is I just need to divide the 5 to the total amount of the balls inside this box. So this probability of success in a binomial trial is actually the same as the population proportion. So what we can do is we are going to estimate the population proportion. So let me give you a couple of examples of the population proportion. For example, you would be interested to know what is the proportion of students in Uzbekistan who likes online learning, distance learning. So it's really difficult and infeasible to know for us the exact numbers because in this case, you need to go through each student and ask his or her opinion, which is not so easy. So what we can do is we can estimate this. We can say, hey, so the proportion of students who likes distance learning is, for example, 55%. Or you would be interested to know what is the population proportion in the whole country who likes watching football. And this is also not so easy for us to do if you'd like to know it exactly. So in this case, we need to go through all the people in the country and ask their opinions, right? So what we can do again, we can estimate. We can say, hey, so the population proportion who likes football is going to be approximately this percentage. But and how we get this estimation? So what we can do is we can take a sample and calculate the proportion of the sample, and this is going to be our point estimate. For example, if I would like to know the percentage of students who likes online learning, I'm going to take a sample by choosing different students from the different years, from the different universities, and then I'm going to ask this question, and depending on the results of the sample, I'm going to extrapolate my estimation into the whole population of the students. So this estimation where I take a sample and calculate the proportion of the sample is called the point estimation. For example, in a survey of 1,250 US adults, 450 of them say that their favorite sport to watch is baseball. Find a point estimate for the population proportion of US adults who say that their favorite sport is baseball. So basically, I would like to know what is the proportion of US adults who likes baseball, right? So what I'm going to do is I would like to choose a sample of 1,250 adults only. Then I counted that only 450 of them, they said that they likes baseball. Then I would like to calculate the proportion of the sample first of all. So the proportion of the sample is denoted as the p hat. It's going to be equal to the number of the successful cases, right? So number of the cases who likes the baseball, so 450, divided to the total amount of the people in the sample. So this is going to be equal to the 0.36. So this 0.36 is the sample's proportion. And at the same time, this is going to be my estimate for the whole population. So I can estimate that the population proportion in US who likes baseball is roughly 36%. And the problem is just estimating the population proportion just 1 point with just 1 point is probably not so good. So, and also it doesn't really give us the mathematical tools to control the precise answers here, right? So this P is, yeah, doesn't really depend on N, and I don't know what kind of mistake I'm doing. So in order to do this, the better estimate of the population proportion would be to create an interval around this estimate. So we calculate the samples proportion, and then we are going to add and subtract some error margin from this estimate in order to create the confidence interval. And we can control the size of this confidence interval actually because of this formula for the E. So here the E is called the error margin. And actually it depends on many things. So the formula to calculate error margin for the population proportions is equal to this one, where the ZC is going to be the critical point depending on the confidence level. So this critical point is going to be different. P hat and Q hat is going to be the samples proportions. We take a sample with a size n. So this is the sample size. Then we calculated a proportion of the samples. This is going to be denoted as P hat, and the Q hat is actually calculated by subtracting P hat from the 1. So this is how we need to calculate the Q hat. So we are going to come back to this error estimate formula. We're going to do an example. So now let's concentrate on this critical point. So again, we're going to find, so if you remember how we calculated this for the mean, so we are going to use the normal distribution in order to calculate the confidence level. So our confidence level basically tells us how much I would like to be confident about my interval. So talking about mathematically, it means that, hey, what is the probability that the population parameter, population proportion, which I don't know, is going to be in my interval. So if I would like to be more sure, if I would like to increase this probability that population proportion is going to be in my interval, then of course I need to just increase the size of the interval, confidence interval, right? So again here, so we are going to define the confidence level as the area under the normal distribution curve, and this area is going to be in the middle. So these 2 points, which are basically dividing this area, are called the critical points. And we find those critical points and plug those critical points into the error estimate in order to calculate the confidence intervals. So let's discuss how we can calculate the critical points. For example, when the confidence level is equal to the 90%. So the confidence level is 90%, again, means that probability that the population parameter is going to be in our interval, which we're constructing, is equal to the 0.9. So if I would like to know what is the critical points, again, I need to use some properties of the normal distribution. So since the normal distribution is symmetric, then the areas on the tails are going to be equal. So it means that both of the areas on the tails should be per 5%. So the overall area is going to be exactly 100%. And now if I would like to know what is going to be this critical point, I need to use the cumulative distribution table. So the cumulative distribution table tells me what is the area under the standard normal distribution curve or under the normal distribution curve until that point, right? So the area until this point is going to be this area, which is 5%, right? Plus this area, which is 90%. So the area until here, it's going to be equal to the 95% or 0.95. And what I have to do is I need to know what is that critical point so that the area until that critical point is going to be equal to the 0.95. In order to know that critical point, we need to go to the table of the Z table. And inside this table here, I need to find this area, 0.95, or a number which is close to this. For example, the closest number is going to be roughly here, or in between this one and this one, probably. So this number is the area which I'm looking for. So what I have to do is I need to find a critical point. So I'm going to find a point from the first row and from first column. So it's going to be first column and first row. So 0.6 plus 0.04, it means that my critical point is roughly 0.64. It means that the area until 1.64. So it means that the area until 1.64 is going to be roughly 0.95. So now once we know the critical point, we can just plug this into the error estimate and calculate this, right? So let's do an example. So construct a 90% confidence interval for the proportion of the US adults who say that baseball is their favorite sport to watch. So previously, we've calculated, we took a sample of 1,250 adults, and we found out that 450 of them, they like baseball. So this information is enough for us to calculate what is the samples proportion, which is going to be equal to the 450 divided to the 1,250, which is going to be equal to the 0.36. So I'm going to calculate the Q hat as well, because I need this in order to calculate the error estimate. It's going to be equal to the 0.64. And now we can calculate the error estimate. It is going to be equal to critical point times the square root of P hat times Q hat divided to the n. So again, so the critical point, we've just calculated this or found this previously. So for the 90% confidence interval, it's going to be, for the 90% of the confidence level, it's going to be 1.645 exactly. It's going to be a square root of 0.36 times 0.64 divided to the 1,250, which is the sample size. And if we calculate this, it is going to be 2.2%, I guess. So 0.022, or we say this 2.2% for the simplicity. And now we can construct the interval. So our interval is going to be P hat minus the E and P hat plus the E. So this is going to be our interval. So numerically, it's going to be equal to the 0.338 and 0.382. It means that the amount, so the proportion of US people who likes baseball is within this interval, and we are sure about this interval for 90%. So I would like to discuss with you a couple of more things. So I would like to discuss with you a little bit more analysis on the error margins. So if you remember this, the formula for the error margin is equal to this one, where we multiply the confidence interval and divide this to the sample size, right? So what I would like to do is, so as a statistical analysis, so if you would like to make the statistical analysis on some questions, so it is of course important for you to create the confidence interval when you choose the sample and calculate its statistic, for example, its proportions, right? But at the same time, for example, if you would like to get a better confidence interval, or better, it means that a smaller interval, right? So what you need to do, how you need to choose your sample in order to get a smaller confidence interval. So in order to do this, we need to look to this formula. So here, so N and E are going to be inversely proportional. What does it mean? It means that if I increase the N, the sample size, right, then the error estimate is going to decrease. It means that my interval is going to be smaller, right? So it means that, so if I would like to control the error or control the size of the interval, I need to control the size of the sample. So as more samples I'm taking, so as more sample items I'm taking into my samples, my estimation of the population parameter is going to be more precise, right? So what I would like to do is, let's say, is it possible to calculate the what should be the sample size if I would like to be sure about the error estimate? So basically, if I say, hey, the error estimate should be exactly 1% or 2%, what sample size I need to choose? In order to do this, we need to find N from here. So let's find the N from here. It's going to be E over ZC, right, is equal to P hat Q hat divided to the N. So if I, from the square root, if I take the squares from both of the sides, I will get this kind of formula, right? From here, I'm going to find the N. So the N is going to be equal to, so this N goes to there, and this term is going to here. So it's going to be P hat times Q hat times the critical point Z divided to the error margin in the square. So basically, whenever this term is going to the right, so the fraction is going to just flip over, right? So this formula, which we are going to use in order to calculate the sample size if you are given, for example, the error margin. For example, if I would like to find out was the 90% confidence and within 2% of the true population, the proportion of the US adults who say that baseball is their favorite sport to watch. What I would like to do is I would like to estimate the population parameter where the error margin is going to be exactly 2%. How many people I should include to my sample in order to get that precise interval, okay? So basically, so the error margin should be 0.02. What is going to be the So again, the confidence level is 90%. It means that the critical point is the same as before, 1.645. So now we need to calculate the n. So in order to do this, we need to use the p hat times q hat times the z, which is 1.645 divided to the error margin, which is 0.02 in the square. So if you remember the formula, it was z here and e here. The only problem is you need to also know p hat and q hat. For example, if you are sitting in the lecture of statistics and you've seen this problem before, you might know that p hat is equal to 0.36 times 0.64 times to this number, 1.645 divided to the 0.02 in the square. If you calculate this, you are going to get the number 1,558. It means that you need to include at least 1,558 people into your sample so that your interval is going to be exactly this width. But what if you don't know this p hat? So we knew this p hat because we've seen this problem previously, right? So if you don't have any clue about the p hat, so for example, you're given a new problem where you don't know the sample, right? So you're estimating how big your sample size should be, and obviously you don't know what is the estimate, what is the proportion of the sample, right? So you need to just simply take this as the 0.5 for both of these numbers. Then just plug this to the formula and calculate the size of the sample. So this is it. So this is how we need to construct the confidence intervals and the point estimation for the population proportions.